in the personal information. What you could do is you could sub in this number for x and say, well, if this was negative 7, what would this be? And solve for y, right, and work through this here. You could make this negative 5 equals 3y. No, that's not right. Negative 9. And so y is negative 3. Or you could just look over in the other table and see, well, if this point is on this curve, or straight line, if negative 3, 7, negative 3, negative 7 is on this one, what has to be on this one? Negative 7, negative 3. It's just switching the 2 points, right? It's switching the 2 points. Okay, so switching x and y in the equation is the same as switching x and y in the table of values. Okay, if you switch x and y in the equation, it's the same as switching x and y in the table of values. These are all switched, so this is just going to be all those x values over there become the y values. X becomes y, y becomes x, right? Whatever was here is now here, and whatever was here, except we should go with the color scheme here, this becomes this. Okay, switching x and y in the equation is the same as switching the coordinates x and y in the points. Graphically, it's not obvious what that is. What is this? Now, I've shown this line for a reason here. What is that graphically? The inverse graphically, switching points, right? This point that is, we started with that one. This point that is negative 1, negative 3 becomes negative 3, negative 1. It's a reflection across this line. It doesn't seem like it's why it's in this reflection thing until you look at it. It is actually a reflection, because the other one was replacing y with negative y and x with negative x. This one's switching x and y, which seems different, but it is still a type of reflection, which is why it's in here. Yes.
Is there a way on GeoGebra
to do this? There is not a way to flip an actual equation. That's why I've done it this way, where it just traces out the curve. I mean, it's probably a really complicated way, but nothing where I could then change it to another function. Animate it, sort of. It's traced this out because that was the simplest way I could think of doing it, is just draw this curve, move a thing along it, and see what it is here. But the inverse in this case is not a function. The inverse won't always be a function. Like, I could write it as y as two different functions of x. I could write it as the top piece and the bottom piece, but the inverse is not a function here. Sometimes it is a function, and you can write it using this inverse function notation. Okay, if we want to do this algebraically here, I'm not sure if you've graphed this here, but I suppose we should stick to graphing this. 3x plus 2 looks like this. It's this line that goes through there. I will try to draw a straight line, even though that's not a straight line. If you draw the inverse, I think you'll find, well, you can draw the inverse after and you'll see what it looks like. It is going to be a reflection across this line. You can look for yourself after why it is a reflection across that line. Just pick a few points on there and see where this goes. Like this point that was 0, 2 becomes 2, 0 on the inverse. This point that is negative 2, negative 4 goes to here. No, it doesn't. It goes to here. And you'll see what the inverse looks like. If you want to look at the inverse, I actually think I took out all the stuff about inverse. Inverse algebraically. I have taken it out here, but I'm assuming you know how to do this, or you can really quickly do this for yourself. If we want to find the inverse algebraically, I'm going to write it right here. Okay? The inverse algebraically. Here's the original function. Y equals 3x plus 2. The inverse, this is the function. This is going to be its inverse. X equals 3y plus 2. If you can nicely, easily rearrange it to get y equals, without having to do plus or minus or anything like that, it's going to be a function. This one actually is a function. It's another line. If you move this over to the other side and make it minus 2, x minus 2 equals 3y, and then I have to divide by 3 here, right? So I'm going to end up with that thing that I just wrote here, x minus 2, divide by 3. This is the inverse. This is the original function. If you switch x and y and then isolate y, that gives you the equation of the inverse. You did that in grade 11. You can apply it to some of the new functions that you've learned this year, like logarithm functions and inverse antilogs. Notice that the original function had what two operations involved? It said take a value, multiply it by 3, and then subtract 2. Let's just write that out here and think about it. This function says multiply by 3 and then add 2. What does this function have in it then? It's the inverse. The word inverse means kind of the opposite operation. This one says take something and multiply by 3 and then add 2. We actually talked about inverses when we talked about anti-logarithms. If this one says first multiply by 3 and then add 2, if I'm going to undo those things, how do I undo those things? First I'm going to subtract 2, right? And then what am I going to do? Divide by 3. If I tell you, I think the operation or the sequence of steps I used before is if I'm going to leave the room today, I have to walk over to the door, or I should say walk to the door, right? Didn't I use this with you?
Yeah.
Walk to the door and then
Place hand.
I don't want to make it too complicated, but I'm going to I'm going to walk. Okay, let's simplify this. We're complicating it with the thing that's supposed to simplify it. I need to go out the door, okay, out the door, and then I need to close the door. Let's not worry about locking it, right? I need to do it in that order. Okay? If I close the door before I go out the door, I'm not able to leave, right? This is first, this is second. If I want to undo those things when I come back in the morning, I need to undo this first. It was the last thing I did leaving. It has to be the first thing I do coming back. I need to undo it, which is open the door, and then I have to walk in the door, right? So you're working backwards, you're undoing them in the reverse order. So if this says multiply by 3 and then add 2, I don't divide by 3 first. What do I have to do first? Subtract 2. I have to undo the last thing I did, and then I got to undo the other thing. If you want to write the inverse of this function, multiply by 3 and add 2, I have to subtract 2 and divide by this. If you come up with some kind of complicated function, which you could maybe do for yourself now, let's do this and say, I am going to raise this to the third power. Then I'm going to do something first here. Let's make some crazy function. We're going to add 7. We're going to raise it to the third power. We're going to multiply it by 4. And we're going to subtract 2. I would like you to try and write the inverse function right away without going through all the complicated steps. I will pause while you do that, except really quickly say them. First add 7. Raise it to the third power, multiply by 4, subtract 2. So if you want to undo those things, you can do them. I'm going to say, if I was to go back now, the last thing I did was subtract 2, so the first thing I'm going to do is add 2, right? Then the next thing I would do, what's going backwards here, right? So I got rid of that. I would multiply by 4 originally, so instead I would divide by 4, right? So I've gotten rid of this, and I've gotten rid of this. I raised it to the third power here, so the inverse of that is going to be I'm going to cube root this. and then I got rid of this, and then I did this, right? So I added 7, so I'd have to subtract 7. If you don't like that, which is sort of the intuitive way, you can take the original thing and go through the steps you did for in grade 11. The steps you used in grade 11 were switch X and Y and isolate Y, right? So put an X here and put a Y here, and then just undo all the operations. Okay? I'm sure you can do that.